Hello folks, let's come back with the next video of this exercise 7.1. Here now it's the 16th problem that we are supposed to be doing in this exercise. So let's take this. It's also very straightforward. You just have to write the integration like this. This is 2x dx actually, the first one. Next it is 3 cos x dx. And then the next one it's e raised to x dx. So everything is direct. We can get the integral directly. So 2x2 moves out. X derivative is x squared over 2. So it is 2 times x squared over 2, and because we have the formula x raised to n plus 1 over n plus 1. By that you will get this. 3 can move out, cos x, the integral is sin x. So it will be sin x and e raised to x as it is plus c we cannot forget. The 2 can cancel. That's it, quite simple. Let's take the 17th problem. It says it's 2x squared minus 3 sin x plus 5 root x dx. Alright, so that way when we get the integral, it will become integral of 2x squared dx minus 3 sin x dx, and here it's 5 root x dx. Again, this is going to be quite simple to take the integral. The 2's out. Integral of x squared is going to be x cube over 3 because we know x raised to n plus 1 over n plus 1. Then sin x, we know the integral is minus cos x. So that way. And for root x, we know x raised to half is going to be x raised to 3 over 2 over 2 over, also over 3 over 2 plus c. Let's just rearrange this. 2 over 3x cube plus 3 cos x. The 3 over 2 becomes 2 over 3 as we saw in the previous problems. 10 over 3. X raised to 3 over 2 plus c. Writing the integral is very easy actually. If it's 1 over 2, it becomes 3 over 2 in the integral. If it's 3 over 2, it becomes 5 over 2. If it's 5 over 2, it becomes 7 over 2. And in the numerator, just write the reciprocal. So simple. So that's about the 17th problem. We can really quickly move to the 18th one and see what it says. I is integral of sec x times sec x plus tan x dx. So that can be written as such we cannot get the derivative directly. So let's the integral directly. So let's open up the bracket. And so you have the first one as sec squared x dx. Second one as sec x tan x. That's it. So that's a ready-made answer for us because sec squared x we know that the integral is tan x and sec x tan x is sec x. That's it. That's our integral. Once we open up. Let's go to the 19th problem which says that it is sec squared x over cosec squared x. Yeah. So that is sec squared x over cosec squared x dx. Apparently it looks a little impossible, but then let's for making ourselves comfortable, let's go in for sine and cos. Maybe that will make it very comfortable for us to work with. So here this is going to be 1 over cos squared x and this is going to be 1 over sine squared x dx. When we rearrange, division by a fraction is multiplication by a reciprocal. So that way it will come to 1 over cos squared x divided by 1 over sine squared x, that is multiplied by sine squared x. So it will come to sine squared x over cos squared x, which is tan squared x. That is tan squared x dx. But there is a bit of problem here because integral of tan squared x directly we don't know. We are not able to get the integral directly, but we can use a trigonometric formula which says that we know that 1 plus tan squared x is sec squared x. So maybe we can use that. And we can call this as, instead of tan squared x by the identity, we can call it as sec squared x minus 1 dx. It's the same. By the identity we have used this. The advantage is that the integral for both of these exist. So you'll get integral of sec squared x, we know is tan x. And integral of 1 dx is going to be x plus c. So that's how things become easy for us once we get it in terms of sine and cos. Let's quickly move to the 20th one which says that it is 2 minus 3 cos, 2 minus 3 sin x over cos squared x dx. Now the same problem persists here. Apparently directly we are not able to do it. So let's go to the respective functions and see how we can work with it. So let's try and kind of distribute 2 over cos squared x minus dx minus 3 sin x cos squared x dx. Let's work with this. 1 over cos squared x we all know is sec squared x. So sec squared x dx and 3 outside. If you carefully see, sine over cos squared means sine over cos times 1 over cos, if you want. You can call it like this. Sine over cos, sine x over cos x into 1 over cos x, So when we write it, this will come to tan x and sec x. So integral of sec squared x we know is tan x, and tan x sec x is sec x plus c. That's about it. So that's fair and convenient. This is how we get across doing our problems. So here we finish the exercise, not exactly finished, because we've got the MCQs also over here. There is a problem number 21, 22, and yeah, 2 MCQ problems. With that we can meet in the next video, and in the next lot we'll have there are more functions coming whose integral we'll be seeing, and so on. So as I always tell, please popularize the channel and please spread a word. Thank you.